Hello and welcome. In this lesson, we learn how to use the sign of the first derivative to show that a function is increasing. This is one of the applications of the differentiation. Remember, if the derivative is positive, the function is increasing. Now, look at this example. We have a graph of a function on an interval given a, b. The question, what can you say about the function and its derivative on the interval ab? Remember, derivative positive, function increasing. We can see here that the graph is a graph of a function increasing, as you can see. So that's what we can say about the function. It's an increasing function. And because it's an increasing, the derivative must be positive. Okay. Now, question 2. Given a function f of x equals 2x minus 1, show that this function is increasing on its domain. So we start by finding the domain of this function. This function is a linear function. So the domain is all real numbers, as you can calculate f of x for all values of x. Now, derivative of this function is 2. Derivative of 2x is 2. Derivative of minus 1 is 0. So you get 2. So as you can see, it's a positive constant value. So the derivative is always positive. Therefore, the function is increasing for all real numbers. So we have applied the derivative positive, the function is increasing. Now, the graph of this function is a graph of straight line with slope 2, y-intercept minus 1. And that's your graph. So y-intercept is minus 1. As you can see, the slope is 2. 1 on the x, 2 on the y up. Question 3. F of x equals x squared. Find the interval on which this function is increasing. Okay, so we're going to use the derivative. And we're going to look for the values for which this derivative is positive. Okay. Now the derivative of this function is 2x. This derivative is positive for x positive. So the function is increasing for x more or equal than 0. We know that this continues on the interval x more or equal than 0. So it's increasing on this interval. Okay. Now another question. F of x is a cubic function, as you can see. We were asked to find the intervals on which this function is increasing. Again, we're going to use the derivative. Okay, so we calculate the derivative. So it's 3x squared plus 2 times 2 for 4x. Then we look for the critical values where the derivative is 0. Okay, so you put 3x squared plus 4x equals 0, factorize, and then get x equals 0 or 3x plus 4 equals 0. That gives you the two roots of the derivative, 0 and minus 4 over 3. Using these two values, we can find where the function is positive and where this derivative function is negative. Now, this is the table that summarizes the sign of f prime and as well where the function is increasing. So we use the two values, minus 4 over 3 and 0, for the values of x, as you can see. This row is for the values of x. So x takes the values in the domain. This is a polynomial function. The domain is all real numbers. That's why I include all the numbers from minus infinity to plus infinity. The two numbers here are the critical values for which the derivative is 0, so I put 0 for the derivative. Then for the sign, it's plus minus plus. How do I get this sign? Very simple. Just look at your derivative. Is a quadratic function. Any quadratic function that has two roots like this one, the sign between the roots is always opposite a, the coefficient of x squared. Coefficient of x squared is positive, so between the roots should be opposite, so you get it negative. Outside, the same value, the same sign of a. Another way to find out the sign is to take any value anywhere. For example, I take a value here between -4/3 and 0. Let's take -1 and substitute in your derivative and see what sign do you get for this value. So f -1, when you calculate, you get it -1, so it's negative. And because it's negative, the function f is increasing on both intervals. Which intervals? It's where it's not negative, which is here. Here it's positive, here it's positive. You can substitute as well with another value here. For example, 1. If you substitute with 1, you get 3 plus 4, which is 7, and it's positive. You can see you get it positive here. And the function is increasing where the derivative is positive. It's positive on this interval and this interval. So the function is increasing on these two intervals. Okay. -infinity to -4/3, which is this part, this interval. And the second one is from 0 to plus infinity. That's it. And I hope this helps. Remember, f prime, the derivative is positive. That gives you the function increasing. Thank you for watching.